Today we're going to talk about the two different competing theories of the universe, the geocentric theory versus the heliocentric theory. The geocentric theory is the belief that the Earth is at the center of the universe and everything revolves around it, and also that the Earth is stationary and not moving. But that seems kind of crazy, right? I mean, everything we know today tells us something different than that. But think about it for a minute. Does it feel like the Earth is moving? Don't all objects fall toward the Earth? Doesn't it look like the sun moves around the Earth when you look at it during the day? These questions are the reasons that people believed this geocentric theory for so long. It made sense to them, and it went along with what they were observing in their everyday lives. Claudius Ptolemy was the one that first proposed this theory, which became the system of choice for the Roman Empire, followed by the Greeks. So you can see in this picture here, the Earth is at the center of everything, and everything seems to be revolving around it. In the 13th century, it ended up being adopted by the Catholic Church, which is what gave this theory its grip and really allowed it to hold on for so long. Nicholas Copernicus was the first one to challenge this theory. In the early 1500s, he laid out his view of the universe, called the Copernican theory. All planets, including the Earth, revolved around the sun. He was the subject of ridicule until his death because of this theory. Since no one really took his theory seriously, he didn't end up getting in trouble by the Catholic Church in the way that people who later proposed similar theories did. However, even though he wasn't widely believed, his idea kind of still stuck with some important astronomers, and the challenge continued. Along came Tycho Brahe, who was from a privileged background of Danish aristocracy, so he came from a family with money. So he had a great education and the resources necessary to conduct quite a bit of astronomical observations. He had used the finest astronomical instruments at the time and made the highest quality observations that had happened during that time. But unfortunately, he couldn't let go of the geocentric model. So he used all of his observations to try and support the geocentric model of the universe. He came up with this hybrid model that had the Earth at the center, but all of the other planets orbiting the sun. But then Tycho Brahe died, but his assistant carried on his work, Johann Kepler. Johann Kepler published a work called Astronomia Nova in 1609, and this contained his first two laws of planetary motion. One, that planets move in elliptical orbits around the sun, so notice that already that is challenging the geocentric view because this says that all planets, including the Earth, orbit around the sun. And then also that planets speed up when they're closer to the sun. And Johann Kepler was actually Tycho Brahe's assistant. And there's kind of an interesting story there because when Brahe died, Kepler and Brahe's family fought over all of Brahe's instruments and all of his observations. And luckily, Kepler won the case in getting all of his observations, but the family got all of the expensive equipment. So Kepler was able to take these observations that he helped Brahe to make and use them to form some of his theories. And these theories of planetary motion are theories that we still use today. And Kepler was coming up with these observations around the same time as this guy, Galileo Galilei, was using a telescope to make some important discoveries. And a lot of people mistakenly think that Galileo invented the telescope, but he did not. He actually used what was called the spyglass then, which was used in navigation and on ships, and he pointed it up towards the heavens for the first time. So while he didn't invent it, he was the first one to point it up to the sky and make astronomical observations with it. And he made many important observations. One was that Venus had phases, that Jupiter had 4 moons that orbited it, that the sun and moon were not perfect. And these observations helped prove the heliocentric theory that the sun is at the center of our solar system. He published his findings, and this made the Catholic Church very upset because remember, they had adopted the geocentric theory as part of their doctrine. He was forced to repent and spent the rest of his life under house arrest. So here are some of his observations. These are his actual drawings. This shows you up here, it shows you Saturn and what he observed as the rings there, and then also the different phases of Venus. And here is a picture of Jupiter with the, you can see the little starry things there are the moons orbiting Jupiter, and you can see how they change position each night. And then also he took some detailed observations of the moon and saw that the moon was not a perfect sphere, but it was a cratered had highlands and lowlands, and he was the first one to discover that. So finally, people started to listen to reason. It took a while for Galileo's ideas to become widespread, and then along came Isaac Newton, who published the philosophy of natural mathematics, and he laid out the universal gravitation and laws of motion. And this was the first time where there was actually someone to explain the physics behind the motion that Galileo was observing. And so he provided the how behind the heliocentric theory, and this was really key in getting it to be widely accepted. So that's it for our PowerPoint on the geocentric and heliocentric theories.